Now, let us look at kinematic link, also called link or an element. So, what is a link? A link is the basic constituent body in a mechanism. We can think of link as a basic constituent body in a mechanism. It is a member or a combination of members of a mechanism that connects other members and have some relative motion between them. For example, let us consider a door which is connected by a hinge to the boundary of the wall. Then the boundary of the wall and our door, then the wall and the boundary are both called link, and the point of attachment for the boundary of that wall is called a node. So point of attachment between links is called node. So, and on the basis of the number of these nodes there can be multiple types of link. For example, binary link, when the link has two nodes. A ternary link, when the link has three nodes. Quaternary link, 4 equal to 4 nodes, and so on and on. Now, joints, also called kinematic pairs. So when two links are joined together, they are jointed by a joint. A joint or a kinematic pair is a connection between links at their nodes which put some constraints on the relative motion between the two links. In the earlier case, when we use the example of the door and the wall connected by a hinge, that hinge was a joint that that put the constraint of motion on our door. When connected by a hinge to the wall, our door could only revolve around that boundary. So that constraint was put by our joint. On the basis so we can classify kinematic pair on a number of factors. For example, on the basis of type of contact, there are two types of joint: lower pair and higher pair. A lower pair is when the links in contact have some area, when some surface of area contact between them, then it is known as lower pair. And when the two links in contact either have a line or some point in contact, then it is called a higher pair. For example, this nut and a screw have a lower pair joint between them, and this ball bearing has a higher pair joint between them. Now, on the basis of type of physical closure, we again have two types of joint: firm closed, force closed. So force closed is the one in which some external force has to be applied on the links to prevent them from separation. And firm closed is when the links are kept together due to their geometry. For example, when we took the example of the nut on a screw, this one, then they were kept together by geometry. Also the ball bearing, they are kept together, these two links are kept together by geometry. So these two were example of firm closed links. And on the basis of number of links joints, so order of a joint is equal to 1 less than the number of links jointed at that joint. Now let us calculate degrees of freedom. Now let us derive some formula to calculate the degree of freedom. And keep in mind that we are calculating this formula only for planar mechanisms. So these bodies can only move in this 2D plane, nowhere else. So let us see. So let us assume that we have three links here: this green body, this blue body, and this ground. So initially, when they were not connected to each other, each body had 3 degrees of freedom. 3 because each could move in a plane, and as we said earlier, rigid body in a plane has 3 degrees of freedom, but not the ground. The ground cannot move, so it has 0 degree of freedom. So initially, when they were not connected to each other, the total degree of freedom or mobility was 3 times n minus 1, where n is the total number of links, which is equal to 3 here. But when these bodies came in contact, so there was some contact between them. So let us consider that when these bodies are joined together. So let us first look at this surface contact. What was the term used for surface contact? We said earlier, it is called a lower pair. So when the joint has surface contact. The motion of our bodies, the motion of the two bodies would be same in the x and y direction. So whenever we have a lower pair joint, the x and y motion of the two links will be the same. So due to that, our degree of freedom is reduced by 2, as and as those will have the same motion in x and y directions. But when we have a line contact or a joint, higher pair joint, then our degree, then so these two bodies will have the same motion in the normal direction, but they could have different motion in the tangential direction. So whenever we have a higher pair, then our degree of freedom is only reduced by 1. Now let us derive the formula. So let us J1 represent the number of joints with degree of freedom equal to 1. These are all the lower pair joints. And J2 represents the number of joints with degree of freedom equal to 2. These are higher pair joints. So the lower pair joints will reduce the degree of freedom by 2, and higher pair joints will reduce the degree of freedom by 1. So the degree of freedom of our whole mechanism is 3 times n minus 1 minus 2j1 minus j2. Now this equation is called Kutzbach's equation. Now we can